entering section C. So sections B and C, first floor is about 350,000 square feet. These are the areas where we will be producing the battery cells in the future. A little bit about batteries.
We're doing anything?
Yeah, it's from behind. A little about batteries generally, so you know batteries have a positive and a negative end. These are the batteries that we're producing. Curious. So the positive end is the cathode side and the negative end is the anode side. We'll be walking through the cathode side of our facility today, but just keep in mind that there is a parallel process that's built out on the other end of the building.
Is the factory going to the new paint smell?
Large sections are automated. You'll actually see some of our automated guided vehicles. Yeah, we do a lot with robotics here, or we will do. This room we're coming up on is cathode mixing. This is the first step of the battery making process. This is where we create a slurry and then coat it on a film. It will happen in the next room. So as you can see here, it's pretty empty. This is because we're building this building out in phases. So on the other side of this glass machine is the first phase of our mixing room, where you're standing now with the second phase. With our partnership with Panasonic, we've brought over some really proprietary high-tech technology that's never been utilized in the States before, that's very particular at Panasonic, so they're very sensitive about their equipment, which is why in certain areas of the building you will see sheeting up that you can't see the specifics of their machines. This next room we're progressing into is cathode code dry, and we have some engineers here who will act as experts.
Welcome.
Yep.
All right, welcome. My name is Jacob Miller. This is Ryan Melser. Together we're on the factory design team, responsible for thermal, mechanical, and chemical systems here at the factory. You just walked in from cathode mixing, where we receive our dry, active material that gets, that's one of the two halves of the battery. This is the cathode, and anode is over there. In this room, we are applying that powder to a metal foil that gets used further downstream in the processes. You can't directly apply a dry powder to this metal foil, so what happens in the mixing room is that dry powder is mixed with a solvent, turned into kind of a wet slurry, pumped all the way into this room. It actually gets pumped all the way down to the end of this massive oven here, where we bring in a roll of very thin aluminum foil. We unwind that roll, come through a coating booth at the very end. So that slurry that we just mixed, kind of like a printing press, gets applied in a very thin layer right on top of that already thin layer of metal. That metal then moves towards us through the oven, and in each stage of the oven there's a very specific amount of airflow coming in and out of each chamber at a specific temperature in order to evaporate that solvent. And by the time we get to the end here, all the solvent is gone, and what we have left is a solid piece of active battery material attached, rigidly attached to the metal foil. Then turn vertical, and I'll go all the way to the top, flip over, so the bottom of the foil now becomes the top. We coat the other side. There's another coating booth up there. That gets dried going all the way through the oven to the end. So at the end we have a very thin piece of foil with battery material on both sides. I mentioned that there's air going in and out of each chamber of the oven. That air, instead of just dumping it outside, we actually recover all of it. There's those ducts at the very far end of the room. goes into the next room, which is an NMP recovery system, or a solvent recovery system, where we actually strip all that evaporated solvent back out of the air, clean it, return the air back to this room. So the air actually goes in a complete closed loop and doesn't leave the building at all. The stripped solvent then goes outside to our utility yard, where we treat it and clean it in a refining system and send it right back to the slurry mixing room, where we use that in a closed loop as well. Okay, guess I'm getting told to move on. Just want to mention that this oven used to take a lot of electricity, but through Panasonic and Tesla engineers working together, we've actually been able to reduce the energy usage by about 80%. And that's kind of our big projects going forward, to cut energy usage wherever we can.
Good job.
Thank you.
Thank you. When we progress out, just notice that the ceiling height in here, actually, you're looking at the bottom of the 3rd floor. So this building is currently 4 floors, but the 2nd and 4th floors are electrical mezzanines. So they just allow electrical and ductwork. And these were designed around the shape of the tools that we were installing. So that room has a 2-story tall tool, therefore the 2nd level doesn't reach there. If you look on your right in these little rooms, we are still building them out. This is still an active construction site. Behind here will be a facility for, well, a room for the cans themselves, the pressing cans, as well as the top caps. Which means we're crossing from section C into section D. If you'll notice, the floor in here is epoxy. This is to support our clean levels. The battery making process requires a very low particulate level in the air and in the room around it. So these are clean spaces while construction is going on. We require that everyone work through these and maintain certain cleanliness levels for their tools. This room is cathode press. This is the next step in the process after cathode coat and dry, which we have 2 experts around the corner to tell you about. But while you're walking through, just note the tape on the floor and any sort of Cuban or tour top. This is actually intended for our AGVs, our automatic high vehicles. So some of them were left open, some of these cracked. You can see the magnets set in them. This is what guides the AGVs.
Yeah, it's a larger scale, more than same thing.
I get a lot of questions about these things. These are actually cell collectors, so we'll just talk about them meeting confidence levels. Any questions? Oh, thank you.
Hi.
How are we doing? How's the tour going so far? Way too fast. Yeah, it's a lot. Yeah, I'm coming in here all the time. It changes every day too.
Yeah, I've been here for 7 months, and I mean, almost on a daily, it's something different, something new. New components are being added, new rooms are being finished, new tools. Every day is exciting. All right, guys, come on in.
Come on in, guys. You get to see Elon speak.
Yes.
Yeah, pretty awesome. That was my first time seeing him speak live too, so that was an experience for me. My name is Matt. I'm an engineer on the factory design team.
And I'm Brian. I'm an engineer that kind of oversees the installation of this equipment.
And we're in cathode press right here, so we'll tell you a little bit about what's going on here. You guys just came from the oven room next door. So at that point, we've evaporated all of the solvent that was used in the mixing process and in the printing process. So now we're left with just the active material on the electrode that's deposited on the aluminum foil. So what we're trying to do now is get rid of all the air that's there from where the solvent used to be. And we're trying to control the thickness of the electrode down to the thickness that's about the size of a human hair in diameter. It's micron scale thickness at that point. So what we're trying to do is control to a specific porosity of the material that allows us to control the electrical conductivity into and out of the electrode. We're trying to compress this as much as we can, but if we, it's really a precision job. If we compress it too much, we actually end up interfering with the molecular structure of the material itself. And the lithium ions won't really travel into and out of the electrode as they should. We're creating internal resistances in the cell. So we're trying to stay away from that, while at the same time trying to maximize our energy density and trying to pack as much material as we can into each cell. So let's go take a look at how this happens.
Yeah, I'll walk you guys through the material flow. From coat and dry, the room we were just in, that coil with the active material on it now actually is fed into what we call the ASRS, Automated Storage Retrieval. This is kind of our factory buffer storage space. Feel free to come inside and take a look. Check it out, it's pretty cool. So this stores material that's in being processed. So it kind of builds up a buffer. Some processes are faster, some are slower. So this builds up a little bit of a buffer so we don't starve any one process in the line. This system in here actually feeds processes on third floor and first floor. So it feeds several different rooms from this area. What you're seeing is basically each of these bays on the rack, each of these units, is for one coil. So one coil gets stored there. There's a crane that runs down the center of the room. It'll go retrieve a coil, it'll bring it down, and it'll place it onto an automated guided vehicle, an AGV. So that vehicle or that robot will follow this track you see on the floor. It's just a magnetic strip. It'll come out of this space.
So that's it. You're an engineer talking to engineers.
The roller press area.
So lay on to that.
The coil from the AGV comes to the piece of equipment and it gets loaded on these spindles. So the AGV does all of this. This component right here is going to take the coil, it's going to unwind it and send it through the roller press. So the roller press is kind of hidden back here under this plastic sheeting, but really it's two large hydraulic presses, about 4 tons each, and it's going to compress that foil down to the thickness that Matt had mentioned. As the foil passes through the press, it gets wound back up in a rewinder, so it's coiled up again, placed onto an AGV, and it goes back into the buffer racks, and that'll feed the downstream processes. The foil exiting the press is about half the thickness of the was going in. And like I said, that's pretty critical to the performance of the battery. It's a fairly automated process. There are operators in here that kind of monitor the equipment. Otherwise, the AGVs are kind of handling the material flow in and out of the room. As you guys work your way out of the room, you'll see an AGV that's charging along the wall. It holds 2 coils on that AGV, and that's what you'll see kind of working its way around the room when this is up and running.
Will this room be much more dense than the equipment at the end?
So this is about what it'll look like for one cell manufacturing line. We'll double this on the other side of this wall. Sections B and the outside area you walk through, we're practicing a little more dense layout in that space. It'll be a little bit closer, but you do need enough space for AGV parts to go through, so that's a meter and a half. There's maintenance requirements, things like that.
What kind of throughput do you have?
How
How long does it take to run a process of oil?
So the output's around 1,200 battery cells an hour is the equivalent. So one coil will actually feed through the system at about a meter a second. So it's fairly quick, especially considering the tolerances that we're trying to maintain, so that micron level tolerance. Cool. Okay. Great, appreciate it.
Thank you. Yeah, that's it.
All right, if y'all come around here, you can see one of our AGVs. Fun fact, it plays music as it goes. We've only heard it play Indiana Jones, but I've heard it's got quite a repertoire. That's pretty good. It's a pretty neat little tune. So as Brian mentioned, this side of the room will be the next phase of production. So having this new wall here allows us to produce batteries on one side while we build out another side. I like to have the hall to give you a good perspective as far as the different floors of the building. So if you look up there, you can see over the ceiling, you'll see into the second floor mezzanine level. That deck right there is the bottom of the third floor. So those